any moment, lightning will strike the Earth 1,000 times a second, and countless storms will tear through the atmosphere. Yet these phenomena are but fleeting glimpses of a far more powerful force. Today, a global search is underway to unravel the mysteries of Earth's climate. Over time, the climate of the Earth changes as dramatically as the seasons. But only now are scientists beginning to find out how and why. This is the story of their search. It begins with the fragments of a giant puzzle collected from around the world. An incredible saga is beginning to unfold of droughts and searing cold, of warm spells and eons of ice. The pieces are everywhere, in the corals of a Caribbean paradise, and beneath the sands of India in the pollen of simple plants. They can be found in a limestone cave in New Zealand and in the high reaches of the Swiss Alps. There are pieces of the puzzle in stones of an Antarctic desert and in the shells of microscopic creatures found at the bottom of the sea. The picture now emerging is one of dramatic climate change that will affect all of us on planet Earth. Join us now on an intriguing journey across time and continents as scientists piece together the puzzle of Earth's changing climate. Through eons of evolution, the great array of life on Earth has developed strategies to cope with the changing climate. Driven by some mysterious internal time clock, some birds travel thousands of miles each year to escape the onset of winter. Animals that cannot flee meet the challenge of a climate turned extreme in numerous and ingenious ways. They adapt by foraging or hibernation. The great chain of life reflects the continuing drama of Earth's changing climate. The fate of human endeavor may also be linked to our inconstant Earth. An unusually benign climate coincided with the rise of civilization, perhaps even fostered its development. Indeed, civilizations first flourished in regions that are truly harsh today, in the searing sands of the ancient Middle East. The inescapable effects of climate change also may have been an important factor in human upheavals throughout history. South of the Himalayas, where India meets Pakistan, lies the great Rajasthan Desert, the most populated arid region on Earth. For thousands of years, people have scratched a living from this bleak world. On sparse desert grasses, they raise domesticated animals and carefully guard what little water can be found. Here, water is more precious than gold. It comes but once a year. For weeks at a time, the monsoon lashes India with steady sheets of rain. Usually, summers are wet and winters are dry, but the monsoon reverses the pattern. The monsoon has fueled the Indian breadbasket for millennia. Deep in the Rajasthan desert, these temples at Ossian bear mute testimony to the spiritual values of an ancient and prosperous civilization. They are symbols of the many cultures that have disappeared, caught in the vagaries of time and climate. As archaeologists recover the ruins from the sands, so too have scientists discovered an archaeology of climate. The ancient city of Lothal, once the seaport of the Harappan culture, now landlocked by the desert sands. For 1,000 years, the Harappans prospered here as farmers and distributors of grain. The University of Wisconsin is an expert on the monsoons
Precipitation.
Bryson has also wondered about the disappearance of the Harappans. Many archaeologists believe they had been weakened by a succession of invasions. Bryson's curiosity led him to Sambar Salt Lake, where he found another answer.
Stratified lake sediments like this are like a book in which the history of the climate of this region has been written. Because in those layers, each year in its history over the last 10,000 years, plant pollen, sand, various things have blown in and accumulated. And we now know how to look at that assemblage of various kinds of plant pollen and charcoal and sand and interpret it to read the writing of history in this lake sediment.
The layers of pollen have revealed a prolonged drought, a time when the monsoons failed and the Harappan culture collapsed. 250,000 people may have perished in the desert. Today, hundreds of millions depend on the return of the monsoons. The study of ancient civilizations reveals that the past can leave long shadows that affect the present and the future. The records left in the Rajasthan cover but an instant in the history of Earth's climate. In a limestone cave in northern New Zealand, the slow drip of water has created a much longer record. Here, scientists have become explorers. With headlamps and protective gear, they seek to push the climate record back further in geologic time. Geochemists Chris and Vivian Hendy.
This is the spot here.
This is where we set up the plastic tubing to collect the water for the radiocarbon dating.
And the next problem was we had to find a stalagmite or a stalactite which would give us a suitably long time record for oxygen isotope analysis. Now, if you took these straws, they go 2 or 3 meters and then they drop off. It's better if we go to stalagmites. Now, here we have a very large one underneath us. This is Mount Egmont.
As water and minerals seep through the ground above, they create the delicate architecture of the cave. Some minerals deposited when the climate was cold differ from those deposited when it was warm. The minerals actually create a chemistry that can be extracted as an historical record of the world's climate. Drip by drip, the cave forms before our eyes. Formations like these have been created over tens of thousands of years, and with them a perfect record of change in temperature and moisture of the past. Concerned about preserving the fragile beauty of the cave, Hendy and his party have hiked a mile through ankle-deep water to look for a specimen that can be removed for analysis. Hendy collects water from these ancient stalactites. The mineral content helps him determine the age of the formations.
Chemistry and composition's been changing.
At Waikato University, Hendy dates and analyzes the limestone layer by layer. His research would confirm a history chronicled by the artists of another time and place. As Dutch artists created their famous landscapes, little did they know they were documenting a dramatic shift in Earth's climate. Today, the Dutch canals rarely freeze, but in the 17th century, more than 3 centuries of unusually severe winters plunged Europe into what scientists now call the Little Ice Age. 100 years ago, the idea of an ice age was inconceivable. A few intrepid scientists had suggested such a possibility, but they were largely ignored. In the middle of the 19th century, a picture began to emerge of a time when Earth's climate was dramatically different. A time when ice ruled the world. For hundreds of years, these towering walls and precariously perched boulders mystified all who saw them. Most thought they were swept here by the Great Flood, so vividly described in the Bible. But in 1837, another persistent observer had a different idea. It was here in the Swiss resort town of Neuchâtel that the ideas of a young scientist would ignite one of the most violent disputes in the history of science. Swiss naturalist Louis Agassiz shocked the scientific establishment when he declared that the world around them was once covered by ice, more than a mile thick. To support his theory, Agassiz pointed to the strange boulders. He matched their geology to mountains hundreds of miles away. The rocks were simply too large to have been moved by floodwater. Nearby, in huge sheets of rock, he found grooves and channels. Elsewhere, he observed bedrock that was amazingly flat, as if sheared by a giant knife. In his notebooks, Agassiz vividly illustrated a distant epoch of extreme cold when ice covered much of the Earth. He called it an Eiszeit, or Ice Age. What was a radical idea for science was obvious to those who lived and worked here. The chamois hunters of the high Alps had long identified the strange rocks as pieces of distant mountains that had broken away and were moved across the land by the glaciers. The lost rocks, like lost sheep, were called foundlings. Agassiz had heard these tales. From these simple and elegant intuitions, he would define his scientific theories. To convince others, Agassiz organized many field trips to the glaciers, a tradition still observed by scientists. Still more startling, Agassiz argued that glaciers were the remnants of a time when ice not only covered Switzerland, but stretched from the North Pole to the Mediterranean Sea. Each summer, scientists return to explore the glaciers of the high Alps. They hike among the rock and along ridges that so intrigued Louis Agassiz. A glacier is virtually a river of ice. With an imperceptible motion, it scours everything in its path. Like a river, it flows at varying speeds to create treacherous currents called crevasses. Hundreds of feet deep, they can disappear almost overnight, collapsed by the continuous onslaught of the ice. Nearly 1/2 of the Earth's landscape has been carved by such unceasing force. Eventually, we would come to know that not one, but numerous vast and regular ice ages have dominated the planet. For most of the last million years, ice was the normal climate of Earth. An ice age begins when summer temperatures fail to melt the snow from a previous winter. Year after year, the ice sheet grows. Only the tropical climate near the equator can stop its advance. Eventually, the Earth mysteriously warms up, and the ice begins to retreat. But what sets an ice age in motion? No earthbound theory can explain the causes of such dramatic shifts in climate. Intrigued by this mystery, Yugoslavian mathematician Milutin Milankovic sought to develop an astronomical theory that would account for the ice ages. He believed they were caused by changes in the Earth's relationship to the sun. We have long known that the seasons are caused by the tilt of the Earth on its axis. But every 41,000 years, the Earth's tilt varies by a few degrees. Every 100,000 years, Earth's orbit varies from nearly circular to elliptical, moving the Earth millions of miles further from the sun. And Earth wobbles slowly like a top in space to complete a circle about every 20,000 years. The tilt, stretch, and wobble of Earth's orbit change the distribution of energy received from the sun. It was Milankovic who calculated that these changes could trigger the ice ages. After World War II, scientists embarked on a global search for the remains of past climates on the ocean floor. A device called a piston corer is plunged through thousands of feet of ocean and into the muds along the bottom. The explorers would discover that the sediments on the sea floor held a record of the great ice sheets on land. In the laboratories, sea cores are unwrapped, time capsules from an ancient Earth. When the core is dissected, nearly 500,000 years of Earth's climate history is revealed. At the Lamont Doherty Geological Observatory at Columbia University, thousands of cores from around the world are cataloged and stored. They create an unrivaled library of the past. Geologist James Hayes has pioneered in the analysis of sea cores. Interpretation of these ancient records is a milestone in climate science.
Although the fact that ice ages had once occurred was first realized from studying the geology of continental surfaces, continents do not contain a very good record of the sequence of advances and retreats of the great ice sheets. This is simply because the continent surfaces are always being worn away, either by the abrasion of the great ice sheets themselves or by the action of rain, rivers, and wind. Now, all the particles that are washed from the continents eventually end up in the ocean, forming muds on the ocean floor, such as this core. These cores, in contrast to the fragmented record of the continents, contain a complete record of long periods of time.
The cores also contain the fossil remains of tiny organisms that thrived in the ancient seas. When they died, their shells rained down to become the sediments on the ocean bottom. Layer upon layer, these shells form a vast record of changing climate. The fossils of ancient marine life are carefully extracted from the cores. As these tiny glass-like shells are sorted and organized, they begin to tell a story. Different radiolaria fossils reflect changes in seawater temperature. By charting temperature changes, Hayes and his colleagues found a cycle that matches the one suggested by Milankovitch. An ingenious method of analysis would reveal still another matching cycle. In addition to temperature, the chemistry of the ocean also changes during an ice age. The shells of marine organisms record this change. By comparing them through isotope analysis, Hayes can determine when the ice ages occurred. When the cycles of change in temperature and chemistry were plotted, it was discovered that both cycles matched those predicted by Milankovitch. Changes in the geometry of Earth's orbit are the pacemakers of the ice ages. New York's Hudson River is a striking example of the recurring phenomenon. James Hayes.
15 to 17,000 years ago, this valley was filled with a river of ice instead of the Hudson River. At that time, the ice in this valley drained the great North American ice sheet, which was rapidly retreating to the north. The question we must ask now is, will the ice one day return to this valley? The answer to that question is yes. For just as the change of the seasons are controlled by the geometry of the Earth's orbit around the sun, so also are ice ages. As fall will certainly change to winter, just as inevitably the ice will return to this valley.
If Hayes and his colleagues are right, planet Earth may face another ice age, which could reach its peak some 100,000 years from now. 800 miles from the South Pole is Vostok, one of several research stations manned by the Soviet Union in Antarctica. Vostok, which has recorded the coldest temperature on Earth, sits on the thickest part of the Antarctic ice sheet. The arrival of an American transport is a rare sight. This one has brought French glaciologist Claude Lorius, here to share in the celebration of an historic event.
I say three words.
You understand?
Ruski, Amerikanski, Franzuski, Vostok, Karasho.
Thank you.
In 1979, the Soviets began an ambitious project. Their goal, to drill through the 2.5-mile thick Antarctic ice sheet. The technique of drilling polar ice was first developed here in Greenland. In the ice is a litany of endless seasons, as layers of snowfall are compressed over tens of thousands of years. From the ice cores, scientists hope to learn more about the climate that has ruled planet Earth for most of the last million years. The mile-long Vostok core is unique. It contains 150,000 years of Earth's history, from the beginning to the end of the last ice age. Claude Lorius will spend the next 3 months carefully sectioning and preparing the core for shipment to France. At the Institute of Glaciology in Grenoble, he will begin the long and painstaking analysis.
Bonjour.
The Vostok core has survived a journey halfway around the world, yet even here it remains extremely fragile. Even the slightest alteration can destroy its unique value as a climate record. To safeguard the core, the laboratory is sterilized and maintained at temperatures below freezing. To eliminate contamination, only the heart of the core is used for analysis. Each layer is like the page of a diary. A mere sliver reveals new detail. Trapped in the ice is dust and ash, a clue to the action of long-dead volcanoes. More intriguing are bubbles of gas, whiffs of ancient air. Seen under polarized light, the ice becomes a kaleidoscope of color and form. Among these tiny crystals is all that is needed to determine the temperatures and chemistry of the atmosphere during the last ice age. One of the most provocative finds is a record of carbon dioxide in the atmosphere of the past. Coring has confirmed that the carbon dioxide level during the last ice age was significantly lower than it is today. How it got that way is still unknown. For Claude Lorius, there is a new urgency to the search.
If we want to understand current change of our terrestrial environment and eventually be able to predict future conditions, I think it is first very important to establish what were the past changes and see if we are able to understand them and explain them. I think this is a necessity if we want to make projection to the future.
Scientists have found that the story of Earth's climate is locked in the ice and rock all around us. Piece by piece, they have revealed not only the climates of ancient Earth, but glimpsed its future as well. We have learned that, like all aspects of our world, Earth's climate is constantly changing. That more changes will come again is certain. But when? And what will be the consequences for life on planet Earth? Of Earth's changing climate. Through Through eons of evolution, the great array of life on Earth has developed strategies to cope with a changing climate. Driven by some mysterious internal time clock, some birds travel thousands of miles each year to escape the onset of winter. Animals that cannot flee meet the challenge of a climate turned extreme in numerous and ingenious ways. They can be found in a limestone cave in New Zealand and in the high reaches of the Swiss Alps. There are pieces of the puzzle in stones of an Antarctic desert and in the shells of microscopic creatures found at the bottom of the sea. The picture now emerging is one of dramatic climate change that will affect all of us on planet Earth. Join us now on an intriguing journey across time and continents as scientists piece together the puzzle, find out how and why. This is the story of their search. It begins with the fragments of a giant puzzle collected from around the world. An incredible saga is beginning to unfold of droughts and searing cold, of warm spells and eons of ice. The pieces are everywhere, in the corals of a Caribbean paradise, and beneath the sands of India in the pollen of simple plants. At any moment, lightning will strike the Earth 1,000 times a second, and countless storms will tear through the atmosphere. Yet these phenomena are but fleeting glimpses of a far more powerful force. Today, a global search is underway to unravel the mysteries of Earth's climate. Over time, the climate of the Earth changes as dramatically as the seasons, but only now are scientists beginning to they adapt by foraging or hibernation. The great chain of life reflects the continuing drama of Earth's changing climate. The fate of human endeavor may also be linked